from here, cos 3 theta equals whatever you get will be identity 8. I just give you some minutes to try cots in class. Can leave spaces for tan. So what I'm interested in next is equation within quadrants, angles within quadrants. Oh, I just erased this part. I'm not sure I took picture. But I think you guys already completed the task. But I don't think I took the picture. Sorry. I only stopped at this point. So I might not have. So I take the remaining. So, triple angle for cos must be in terms of cosine only. Triple angle for tan must be in terms of tan only. So, let's take note of that. Yes. All right.
So up to here.
I didn't factorize. I only changed something that doesn't look alright. I never factorized. So you got it up to here, up to here, up to here. Then here, you decide to factorize sine. That's not what I did. I'm doing cos. I know. So I'm thinking in terms of sine. Here now, sine is present in all the terms. Did I bring out sine, brackets, everything? I only change this because I need sine. That's the only thing that doesn't look alright. So you look at the only thing that doesn't look alright and change it. There's no factorization. So you are wrong from this line. This line up to this line is still okay.
Wait, so this line?
Yeah. So you look up something that is some anomaly and change it. Has anyone done it? Cos cube, cos 3 theta, sorry? Okay. Does it look like this one? But in reverse, right?
Yeah.
So you're supposed to get what? What did you get? 4 cos 4 cos what? Okay, yeah, 4 cos cube theta minus 3 cos theta. So it's similar.
When he paused.
Okay? Similar. Have you seen your error? Trying to. This, what is that abnormal stuff here? I told you everything is correct up to this point. When I got to this point, this is the only thing I changed because everything is sine.
Yeah, no.
That's not what you're doing.
What are you guys there for?
You just wrote cos bracket again. I told you this is correct.
Oh.
Just change the next step, change what looks abnormal.
Wait, what? What do you mean?
For cos,
I don't know where that 2 comes from. Oh, okay, good.
My brain's not alright.
Can I see yours, Roberta?
Yes.
Or tan? No, off.
I don't want to.
So if your simplification is right, then you're right.
Oh.
Check the. I sent you a picture of. I don't think there's a cube and the formula booklet. I sent you.
You are genius.
There.
Am I doing the right thing now?
900.
Let me see what I get. Okay.
All right, so we're going to have to continue. If anybody has issue with it. So what have you done this time? So where does sine come from again? That's sine squared. Where do you get 2 sine cos? Aren't you using this one? What's your problem? Is everything okay here? All right. Nakita and Karen? Everything good? So far? All right. So we can suspend the tan and do later. So please, let's focus on this. Because I have a target. Hopefully we can meet that target. Okay, hopefully we can meet that target. So if we're able to just get some of this thing out and the applications, then I'm rest assured that we're making progress, okay? Anyways, quickly. So one of the things that we need in solving the trig equations, one of the things that we need in solving trig equations is to understand the signs of these trig ratios in each quadrant. Brandy, please suspend what you're doing and focus on what we're doing now. Is to understand the signs of these trig ratios in each quadrant, which you already know, using that or student take coffee, something like that. And also to see how you convert angles that are more than 90 degrees to angles that are less than 90, or even angles that are below 0. Okay, which some of them are not required. I'm just going to mention that for the record. So, the easiest way I learned this, I remember Mr. Mbrandri, that's the name of my Indian maths teacher. He told me to watch out for a butterfly shape in a circular function. So what does it mean by butterfly shape? Oh gosh, I missed that man. Very good. It's referring to this. Now, those are the regions that we need, and it makes so much sense. Remember, you've done something similar in complex number. When finding the arguments, it's always the angle from where that function is to the x-axis. All right? So if you're looking at the angle for this one in the first quadrant to the x-axis, this is the angle. Okay? For the other one to the x-axis, for the second one, this is the angle. But this line, the purple line here above, will have traveled from here to here. But this is the angle actually in question. Okay? So, by sign-wise, how does this, all this sign, or student take coffee, even, there's no blue on the board, so maybe I'll use blue. So it's easier. So if this is my angle theta here, and this is my theta here, and this is theta here, and this is theta here, in each of the quadrant. Now, if I join this to form a right angle triangle, here also I form a right angle triangle, here I form a right angle triangle, and here I form a right angle triangle. Clearly, this is x-axis, so this is plus x, and this is plus y. Can you see that? In the last quadrant, I have plus x, but I have negative y. Okay? The radius of this circular function is r, and it's always going to be positive. Radius is never negative. In the second quadrant, I have negative x, agreed? But I still have positive y, right? And here I have what? Negative y, and also negative x. So if you find your SOHCAHTOA in each quadrant, so let's say quadrant 1, I call it Q1, just to abbreviate. In quadrant 1, my sine is what? Sine theta is what? Opposite, that's y over x, right? Y over r. Okay? Y over r. My cos theta is x over r, okay? And my tan theta is what? O over a, y over x. You can see they are all positive. In my second quadrant, well, I'm not writing this in a very organized whatever, so take your time to write it anyhow you want. In my second quadrant, what is sine theta? Quickly. I get y over r, agree? It looks messy, I hope you can see it. My cos theta is what? Adjacent over hypotenuse, negative x over r, so cosine is negative here. And my tan theta is what? Opposite over adjacent, y over negative x, which is also negative. So we say only sine is negative, only sine is positive here. So here, the first one, all are positive. Here, only sine is positive. So in the third quadrant, sine theta is what? Negative y over r, remember, opposite over hypotenuse. Okay? Callista, you know you can actually do that at home rather than not participating. What is cos theta in the third quadrant? Negative x over r. And similarly, tan theta is what? Negative y. Negative y over negative x, which is just y over x. So you see that tangent becomes positive here. Okay? Finally, in the last quadrant, Q4, sine theta is what? Negative y over r. Cos theta is what? X over r. Yes. And tan theta is what? So which one is positive here? Cos. So this is what we mean by all are positive in the first quadrant, blah, blah, blah. So this is a short like explanation of how that can be recalled. Now, this, in addition with what I'm going to say next, will enable you to find, for example, cos maybe 720 or cos 450 without the use of calculator. But all you need is the table that was summarized. You only need to know what is 30, 45, and 60. Okay? Rather than giving you, find the sine 60, I decided to give you what is sine 420. What is the connection? Okay? So we look at three things in summary. One is angle that are more than 360. One is angle that are below 0. And for angles that are above 90 normally, how can they be converted back? Okay? So let's look at that quickly. This will enable, this would now be combined with solving equation later. And when I discuss periodic functions, you will see why this actually makes so much sense. When we look at the behavior of sine and cosine graphs, and you see, you look at their periodicity, and it makes so much sense. Later in your physics, I'm very sure, you're going to be looking at wave equation, you talk about amplitude and all that stuff. These are properties of sine and cosine functions. So that should make more sense to you. Okay, now this is what we already know. All students take coffee. All right, so you'll no need to memorize. Well, don't worry about what I did. This is just explanation. The summary you already know. I was just trying to put that on the record for you. The next thing I want to talk about is how to convert angles that are more than 90 to angles that are within 90 degrees. Okay, so angles greater than 90 degrees. Okay, but less than 360. Okay, so again we go to the circular function. The same picture I have there. So if you have a circular function of radius r, it could be radius 1, it doesn't matter. Again, we look at that butterfly-like shape. This time around, I'm going to be applying what we did during the complex number argument. So in my first quadrant, I wouldn't want to draw this 4 times. So hopefully, I can use different color to explain different parts. But sometimes, too much shapes, then it becomes more messy. So for the first, now we're talking about angles that are more than 90, so we don't really need this part. So anyway, I'm just going to write it. In the first quadrant, sine theta, this is my first quadrant. So in quadrant 1, if this is the angle, my sine theta does not change. It's still sine theta. It doesn't change. Cos does not change. Tan does not change. Because the angle of the movement is the same as the angle to be considered. That's what I mean by that. The angle with which that point P, so this is a point P with coordinates cos theta, sin theta. We'll talk about that much later. Now, but if you look at the second quadrant, it moves from here to here. Okay? So this is now my angle theta. Okay? But the angle that we can consider because of the right angle, that we always make use of, for example, is here. So remember when we did a complex number, and we always try to find the argument of the complex number, we'll find the value of this, right? Then subtract from 180 degrees, right? And that gives us the angle we need. Am I making sense? So if this is the angle that I can work out, is this angle acute or not? You know what an acute angle is, right? Is this acute or not? Acute is less than 90. Is this an acute angle or not? Yes. Why am I particular about acute angle? You know about sine 30, sine 45, sine 60 in exact forms. So you don't have problem with trig ratios of acute angle. But that's not what you are given. What you are given is cos 135 degrees. That's not acute angle. How do you convert it back to the acute form? That's what we are trying to do. So if you give me 135 degrees, then I find the acute form of it on the other side, like the equivalent on the other side, the second quadrant. It's actually more or less dealing with 45 degrees on this side. Am I making sense? So, if I'm trying to find my sine theta, so the angle in question, so here, Q2, if I'm trying to find sine theta, all I need to actually do is do 180 degrees minus whatever angle that I'm given. And because my sine is positive here, I don't have an issue here. Again, just watch this. This angle theta is acute. Sorry, it's not acute, sorry. It's this angle. Okay? For cosine, because that sign says, the sign in each quadrant says only sine is positive, then cosine and tangent will be negative. So if I want to find cosine of an obtuse angle, which is an angle more than 90, all you need to do is, it will be negative of the cosine of 180 minus the angle itself. I'll show you this in practical form now. If I want to find tan of that angle, I do what? Negative tan of 180 degrees, which is pi minus that angle in radian format. Now, what does this mean? Everybody, listen. Let me show you this before we move to the next one. So, somebody says find sine 150. 150 is here, but this is the angle that I can make use of in acute form, which is equivalent of whatever 180 minus whatever I have, right? So it's going to be sine 180 minus 150. Why is this still positive? Because I'm dealing with second quadrant where sine is positive. So which means my sine 150 is actually sine 30 degrees. No need for minus. So if somebody asks you what is the value of sine 150, in your head, 150 is within 90 and 180, second quadrant, where sine is still positive. So the answer is still positive. And the conversion, the acute conversion, or the acute equivalence of that is 180 minus that angle. Do you understand that? And this is it. And sine 30 is half, which means sine 150 is also half. Check in your calculator quickly. Okay? Now, let's see in the case of cosine. Let's take cos 135. 135 is obtuse also, right? Is cosine positive or negative in the second quadrant?
Negative.
Negative. So the conversion will be negative cos, and the equation to convert it is 180 minus that angle. Does that make sense? So this is minus cos 45. Cos 45 is what? 1 over root 2. So this is negative 1 over root 2. Check that quickly. This thing that I'm trying to explain is needed, but especially in non-calculator papers. That's why it's very important. Does that make sense? Make sense? Okay? And tan is similar way. That's what we are trying to say here. Why is this also important? Somebody gives you area of triangle. You don't know the triangle, you don't have the shape, and somebody says a triangle has side AB as 6 centimeters. You know, normally you have maybe ABC like that, right? AB has 6 centimeters and BC has 8 centimeters, and the area is 24 centimeters squared. Everybody, find angle B for me, quickly. Quickly. I want to show you something, why this is very important. Find angle B, using whatever you know. I'm not asking you to answer the question, that I'm trying to bring out here. Just do it the way you knew before. AB is 6, BC is 8, the area is 24 centimeters square. What is the value of angle B? The area is half AB sine theta, in case you forget. I should start printing the worksheet that I want to give you as holiday stuff, because I'm not sure if everybody's coming for the summer class. Is everybody coming? What? What is it? Say that again. 19? Huh? Oh no! Sorry. 12. Sorry, I'm sorry. This is 12. I'm sorry, that's 12. 90 doesn't give me what I want. Yes, that 90 is correct, by the way. So I actually did the rectangle triangle instead. What do you have? 30 degrees. Everybody get that? Everybody get that? Yes or yes? Yes. We're almost done. I know you guys are tired.
I know university is 2 hours, but the University of Macau is 3 hours.
Anyway, maybe for postgraduates. For my undergraduate days, all my lectures are 2 hours. And sometimes consecutive, 8 to 10, 10 to 12, 12 to 2, 2 to 4. So sometimes we run away, we go downstairs, get snacks, go back upstairs, third floor, no elevator by the way.
So lectures, do you guys get breaks in between, or is it like the professor talking?
There are different professors, like different lectures. So you're on your own if you leave the class when the other guy comes. But anyway. All right, listen. You got 30, right? So I believe this is what you did. Area. So if we have like a sketch, we don't know if this is the sketch, we just decide to draw something. It could be nonsense, nobody cares. 6, 8, and this is the angle theta, for example. So the area is half times 6 times 8 sine theta. And this area happens to be 12. Someone is being noisy. So this is 24 sine theta equals 12. So sine theta equals 12 over 24. And from what you have just, from this is that. So theta is arc sine of 1 over 2. And from our ratio, from our table, this is 30 degrees. So the question you might have, this is what you know in IGCSE so far. Okay? So in IB, the question like this will tell you, sketch the possible triangles that follow this, whatever, that this, for which this information is true. But what you have done is just one triangle. So you are thinking of this. 6, 8, 30 degrees. What you fail to realize is, this is another. Why is that? Because sine 50 and sine 30 are the same. Does that make sense? The sine rule also that you knew from IGCSE does not have ambiguous cases. Ambiguous case means, it's not clear. If I look at it this way, I'm right. If somebody looks at it this way, they are also correct. That's the case of ambiguous stuff in sine rule. But it's in your own syllabus. Ambiguous cases of sine rule. So if this was a sine rule problem, sine A over A, sine B over B, and you find arc sine of something, and you get the angle, there are two possibilities for the angle, because we are dealing with sine. So the acute one is by default what the calculator gives, but you can also have the obtuse version. So this will be or theta equals 180 minus 30, which is equal to 150 degrees. So there are two possible values of the angle theta. So if